Hello everyone, and we've got here a GCSE probability question, and in my opinion this is a perfect example of an extremely tricky tree diagram question for dependent events. So although this is actually only question 14 and it's a few questions away from the end of the paper, I think that this is by far the hardest question on the paper so far compared to the questions that come after it. So this is a very, very difficult one. Let's have a look. So it says there are 9 balls labeled 1 to 9 in a box. Lee will take at random 2 balls from the box. Lee says that the probability that the sum of the numbers on the 2 balls will be even number is greater than the probability that the product of the numbers will be an even number. Is Lee correct? You must show how you get your answer. Now this is worth, it is worth 5 marks, but as I say, wow, what a question. So first of all, there's a number of things that are very popular with these more tricky dependent tree diagrams. And this whole idea about odd numbers and even numbers is a really big theme. So I think it might be useful as a first starter to think about what happens when we have odd times odd, what happens when we have even times odd, what happens when we have odd times even, what happens when we have even times even, because having an understanding of this is crucial to answering this question. So odd times odd is odd. Even times odd is even. Odd times even is even. And finally, even times even is even. So that's the pattern that we need to be aware of for the multiplication, for the product, okay? Because remember, Lee's talking about the product of 2 numbers. Now let's consider the same situation for the sum of these numbers, okay? So we're going to now consider the same thing, but notice we have a plus here now, okay, rather than a multiplication sign. So odd add odd, let's think about that. 5 add 5 is 10, so odd add odd is even. Even add odd, okay, so even add odd is going to be odd, because if I have 2 add 3, for example, that gives me 5. The other way around, it's still going to be odd if you've got odd add even, and then even add even, like 10 add 10 is 20, so that's going to be even. So that's our pattern for summing. Okay, so let's write here sum. So that's a really useful piece of information that we're going to need, okay? Now basically there's 9 of these balls in the box. So let's just put them down. Let's just call them 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's just label and see what they are, okay? So they are, we have got odd, 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 even, 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 even. Okay, so let's start to draw our tree diagram based on this now. Okay, so Lee's going to select, this is choice number 1. It's either odd or even. And then Lee selects the second ball from the box. It can either be odd or even as well. Odd or even. Now, the probability that Lee selects odd first time, how many odds are there? 1, 2, 3, 4. There's 5 odds out of the 9. So 5 out of 9. And then that means that 4 out of 9 must be even. If Lee selects an odd one first time, there's only going to be 4 odd numbers in there out of the 8 that remain. Okay, so that would be 4 out of 8. And here would also have to be 4 out of 8, because remember, the branches of a tree diagram need to add up to make 1, each individual branch. If Lee selects an even one first, there'll be 3 even left out of the 8. And then because this has to add up to 1, that will be 5 over 8. So there's our tree diagram showing Lee's selections. Now let's work out what these individual probabilities are going to be. So we times along the branches. So if Lee selected odd, odd, so this is the probability that Lee selects odd followed by odd. That is going to be 5 over 9 times 4 over 8, which is going to be 20 over 72. So that's our probability of odd, odd. Probability of odd, even. So probability of odd followed by even is going to be 5 over 9 times 4 over 8. So again, 20 over 72 there. So that's that one. Now let's have a look at the probability of even followed by odd. The probability of even followed by odd. So probability of even odd is going to be 4 over 9 times by 5 over 8. And 4 over 9 times by 5 over 8 is again going to be 20 over 72. And then finally, our probability of even times even is going to be 12. Probability of even and even is going to be 12 over 72. Okay, so that's our completed tree diagram showing all of our probabilities. Now let's write here, it's going to be really useful. I'm going to write down here sum, and I'll write down P for, let's write down product. Okay, so the sum of the product. Now, using this is where we're going to use our chart here. So if we've got, let's do the sum first. So odd, add odd. Odd, add odd is even. Okay, so that would be even. Odd, add even. So we've got odd, add even would be odd. What have we got? Even, add odd. Even, add odd would be odd. So that would be odd. And then finally, even, add even would be even. So that with Lee was adding them, these two numbers together, that would be even. Now let's look at the product and see, imagine Lee was timesing them together. So odd times odd. Well, odd times odd would give odd as a product. Odd times even would give even as a product. Even times odd would give even as a product. And even times even would give even as a product. Okay, that's perfect. Okay, so that is everything that we've got there for the sums and the products. So now we're almost in a position to be able to answer this question. Let's have a look and see what we've got here. What does it say? It says the following: the probability that the sum of the numbers on the two odd balls will be even. Okay, so the probability that the sum is even. So probability that the sum is even. Let's have a look. So here's our sum. So for even, we want that one and we want that one. So the probability is going to be 20 over 72 add 12 over 72, which is going to be 32 over 72. Okay. An interesting point is quite often if you work these out on your calculator will cancel them down. I prefer to leave them just as they are without being cancelled and then cancel the numbers down like in the final stage. It just makes it easier for a direct comparison. So we found out there the probability that the sum of the two numbers that Lee picks is even. It's 32 over 72. Now let's look at the probability that the product of the two numbers that Lee picks is even. And what's that going to be? So what have we got here? We've got the product even, even, even. So it's going to be this probability, add this probability, add this probability. So that's going to be 20 over 72, add 20 over 72, add 12 over 72. And we work all that out, and that comes to 52 over 72. Of course, as an alternative, we could have done 1 take away the probability of odd. That was an alternative. So 1 take away the probability of odd. Okay, that's fine. So now we're ready to answer the question. So Lee says that the probability of the sums of the numbers on the two odd balls, that's this one, will be greater than the probability of the product, that's this one. So Lee thinks that this is going to be bigger than this. So what we have to put is no, Lee is incorrect. And actually, we can see we've got all of the probabilities associated with that. So we're going to get the marks because we've got the associated probabilities as well. I hope that you found that useful. I personally thought that that was a super tricky question of its type. I think the thing that made that really difficult, I've seen them combine odd and even before, but this is the first time I've seen them combine the idea of a product and a sum together, which I think makes it especially difficult. So really well done if you followed that one okay, and I hope you found it useful, and I shall look forward to seeing you in the next video.